Is it your product?
Yes.
Hydrogen, oxygen, carbon. Phosphorus, calcium, nitrogen. It's easy to transform an ordinary human into a collection of chemical elements.
Would you mind?
No. This is the fate of our films.
Yeah.
However, the audience is large. Million people is watching your film right now.
And you're one of them.
Does this film really exist?
Which film?
The film about quantum mechanics.
I don't know. It doesn't matter. The film can be made anytime.
I hope you won't have to produce it.
Why not?
You are a brave woman.
I have noticed it at once.
That's a bad idea.
Is it too difficult to talk about complicated things in a simple way?
I suppose yes.
Well, we can't tell. Not for everyone, surely. But the cinema's purpose is to show, isn't it?
Yes, cinema should portray.
Oh, but you can't portray anything in atom mechanics.
Why?
The matter is you can see nothing.
I'm afraid you are wrong. I can't see atom, but I can imagine it and then portray it.
Yeah, but it's impossible to imagine atom, so you can't portray it.
Sorry, but I can't agree with you. Human imagination can cope with everything. If you have fantasy, you can imagine whatever you want.
Except things that you can't imagine. Atoms, electrons, protons, all things that quantum mechanics deals with.
There was a great physicist, Rutherford. Have you ever heard about him?
Yes, I have.
Once he said to his students, "Now I know how the atom looks like." He has exactly said, "looks like." Then he drew positively charged nucleus in the center and negatively charged electrons around it. Am I right?
Absolutely.
So it is possible to portray the atom, isn't it?
Yes, it is.
Well, I think he is kidding us.
The thing is that your atom couldn't exist even for a part of a second.
Why?
Let me ask a simple question. How opposite charges collaborate?
They attract to each other. It is a school knowledge.
Surely they're coming together. So, according to your theory, electrons should fall on the nucleus. Am I right?
I'm afraid no.
Why not?
Electrons are in motion. They're spinning around the nucleus like planets around the sun. Planets don't fall on the sun.
Yes, but planets are naturally charged, while an electron is charged.
So what?
According to the classic theory, charged particles should give off light during orbiting and fall on the nucleus.
Oh, we have not dealt with it.
Okay, let's start again. The world consists of atoms. Is it true?
It is like the air.
The atom consists of nucleus and electrons.
You got damn right.
The nucleus is positively charged,
Yes,
and electrons are negatively charged.
yes,
They should attract each other.
they have to.
Has it been checked and proved?
Yes, it was proved experimentally.
So if electrons are immobile, the atom attracts them and the atom ruins.
Sure.
Electrons should move and orbiting nucleus to make the atom to exist. Am I right?
Right.
So according to you, they give off light while spinning in a such way.
Yes.
They lose their energy, right?
Yes.
So they spiral to the nucleus.
We had already mentioned it. Let's start over.
The reasonings contradict each other. There is covering up of mistakes.
Right. Physics thought in the same way.
Have they found a mistake after all?
Sure, according to classical theory, the radiation is continuous.
And it is intermittent.
You got them right.
It changed the whole dynamic.
Yes, the difference is dramatic.
Physicists tried to explain how electrons interact with nucleus. Did they succeed in it?
Yes.
So how does an atom look like?
That is a complicated situation. In this case, an atom has no face.
Should we take it on trust?
Do as you wish.
I would better obtain an evidence.
I consider you as a stubborn woman.
It would be better to call me curious. So the radiation proves intermittent.
Yes. Overall, atoms absorb energy and radiate rounds of energy.
You mean quanta?
Absolutely right. A quantum of energy is indivisible. This is the minimal round of energy.
Well, all of that is clear.
It's a piece of cake.
You might understand why electrons do not collide nucleus.
Sure. That comes naturally.
You're right. It's well said. That comes naturally, but it contradicts the theory. Niels Bohr thought in the same way.
Sorry, who?
Niels Bohr, a Danish physicist.
So how the story ended up?
They decided to trust in nature. Bohr suggested that an electron doesn't fall on the nucleus. Well then, there are such orbits in atom on which electron moves without emitting the light and without losing the energy.
What about the other orbits?
There are no other orbits, only allowed orbits exist. The others are prohibited by nature.
And what about radiation? After all, atoms emit the light, do they?
Of course, but only as quanta, that is like jumps, and only at such moments when electrons transfer from high orbits to low.
There is a highest orbit from which electron can't fall.
Absolutely right, you got it.
Perfect. And now shall we look at atom structure?
You mean graphically using balls?
Yes.
We can't, they are already lost.
Who?
Balls. Didn't you notice that? By the way, Bohr hadn't seen that at first time either.
You see, this is a nicety, we can ignore it. But how clearly all turns. Imagine that atoms have just absorbed some energy. This energy raised our atom on the highest orbit. And on the top orbit of our atom the ball, that is the electron, rolls. He is situated on a loud orbit, and that's why he moves without losing the energy.
Yes, but atom can't remain in this state. He aims to stability and he must emit extra energy.
That's okay. When ball falls, he emits the quanta of light and turns up on the adjacent orbit. Then he again emits the quanta of light and jumps on the next orbit. And this happens until he reaches the lowest orbit. He can't fall now because there is no orbit, no excess energy. And ball rolls on this orbit until the new portion of light will raise him up again.
Great.
Да.